Welcome back. We are looking at Chapter 9 again, Lesson 9.2, which is surface area of pyramids. So if you look at this first part of the key ideas, you see that we're talking about a regular pyramid here. And remember that a regular pyramid has a regular polygon as the base. Regular polygon is a polygon that has the same side lengths and the same angle measure for each of the angles. So if we're looking at this one here on the screen, we're looking at what would be a square as the regular polygon as the base. So you could have an equilateral triangle that would be the base. You could have a pentagon where all of the angles are the same and all of the sides are the same. And so that's what we mean by a regular pyramid. So when we look at slant height, you can also look here and see that the slant height is actually then the height of that triangle. And so when we're thinking about surface area, that is going to be important, focusing on that height of the actual triangle and not the height of the pyramid. We wouldn't need that until we get into volume later. So if you see the formula for surface area of a pyramid is just the area of the base plus area of the lateral faces. And notice that with this example here, those triangles, there's 4 triangles there, and they're all the same. So if you find the area of one of the triangles, you can just multiply that by 4, getting you the lateral triangular faces for the area. All right, hopefully that all makes sense. And now we're going to look at example 1. Example 1 on page 364 is finding the surface area of a square pyramid. As I mentioned earlier, a square is a regular polygon because all of the sides are the same. So when we're looking at this example, you can see that the base is 5 by 5, which is the area of that base then is 25. Each of the triangles you can see are, they have a base of 5 and a height of 8. Notice again, that's a slant height of the object, telling you that the face or the triangle within that pyramid is 8 inches tall. So as you can see, the math was done for you. 1/2 times base 5 and height 8 is equal to 20. But because we have 4 of those, we have 4 of those triangles that make up those faces, we need to add, either repeatedly add 20 or multiply 4 times 20, which gets us the 80. 80 plus 80 plus 25 is 105. And so for this problem, example 1, you would be getting 105 square inches as your answer. Go ahead and try example 1, on your own, number 1 right now, asking you to do the surface area of a square pyramid with a base side length of 9 centimeters and a slant height of 7 centimeters. Again, page 364, on your own, number 1. Give that a try. Hopefully you've tried it. You should have gotten an answer of 207 centimeters squared. All right, looking at example 2 on page 365, you can see that they are asking us to find the surface area of a triangular pyramid. So notice the only difference about this problem is that the base is actually a triangle. And remember, since we are doing regular polygons as the bases, then we know that this is an equilateral triangle at the bottom. We have a base of 10, and we have a height, again, of that base, of that pink triangle. We have a base of 10 and a height of 8.7. So Again, the work is done for you. 1/2 times 10 times 8.7 is equal to 43.5. That again is that pink triangle. We also need to find the area of the lateral faces, so the other three triangles that make up this pyramid. And so you can see there that the slant height is 14. And then again, we're going to have a base of 10 for each of those. So the math is done for you. 1/2 times 10 times 14 is equal to 70. However, remember, we have 3 of these faces, so we have to take 70 times 3, which gives you 210, and then add that to the area of the base, which was 43.5, giving you a grand total of 253.5 square meters. All right? So go ahead and give number 2 on your own a try at the bottom of 365. Again, number 2 at the bottom on your own, number 2 at the bottom on page 365. You should have gotten an answer of 105.6 feet squared. All right, example 3 on page 365 is a real-life application. Looking at this, we are looking at that roof, again, you're going to want to read it a couple times to make sure that it makes sense. A roof is shaped like a square pyramid. One bundle of shingles covers 25 square feet. How many bundles should you buy to cover the roof? Notice, with this problem, we're only asked to work with the roof. So we do not care about, the walls of the house. All we're really focused on is that roof. And then also there's going to be a second step of it is finding out how many bundles of shingles we're going to need to buy. So the first thing that we're going to need to do is find the area of just those lateral faces. And so again, it's a square pyramid. So we need to focus on getting the the 4 lateral faces of the pyramid. So the base of that triangle is 18. The slant height, or the height of that triangle, is 15. So we have 1/2 times 18 times 15, which is 135. So each of those faces is worth 135. We multiply by 4. That gives us 540. So that's how many square feet that we need in total. But remember, the question's asking us how many bundles we need to buy. And we know that one bundle covers 25 square feet. So what we can do is just take 540 divided by 25 to find out how many square feet or how many bundles we're going to need. And so when we do that, we end up with 21.6 bundles to cover that roof. Again, you can't go into the store and buy 21.6 bundles of anything, right? And so we're going to round up in this situation, regardless of if our rules tell us to round up. We're rounding up because of logic and saying that we are going to want to cover the entire roof. And so we're going to need 22 bundles of shingles. All right. Hi guys, I hope that lesson was helpful. What I would like you to work on before I see you later today on Google Meet is page 366 and 367. I would like you to do numbers 5, 7, 8, 9, 10, 11, 12, and then I'd also like you to try number 14. Okay? Number 14 is going to be a little bit more. Make sure that you read it. It is a composite figure. So give that a try, and then we will talk about it at 11:30 if you have questions. All right, good luck. Email me if you need anything.